In this video, we're going to talk about the period of a sine and cosine function and how that can change given a certain equation. So the period of a sine or cosine function we've already defined, and that's the smallest x interval over which the graph completes one full cycle but does not repeat. And this period may change depending on the equation. So in the original equations that we had started with, y equals sine of x and y equals cosine of x, we saw that the period was 2 pi, and I want you to denote the variable that we use for period. We use a capital tau in Greek, that's a tau, t in Greek, to represent the period. So 1 period for the sine and cosine function is equal to 2 pi, and it looks like either this if it's sine, or it looks like this if it's cosine. All right, so what happens if we change our equation to look like this now? Y equals sine b times x, and y equals cosine b times x. Well, the period is no longer 2 pi. We can think of that b as a horizontal stretch or compress. So how do you calculate the period over which your graph will start repeating? Well, we calculate the period by using this formula. Our period tau equals 2 pi divided by b. So let's take a look at what happens if b is a number between greater than 1. If b is greater than 1, what happens to our period? Well, let's say b equals 3. Our period now is 2 pi over 3, which is much smaller than our 2 pi period. How about if b is between 0 and 1? Let's just say it's 1/3. Then our period is going to be 2 pi over 1/3, or 6 pi. So for horizontal stretches, we notice that if b is greater than 1, it's actually doing a compress of our period. Whereas if b is a fraction between 0 and 1, it's doing a stretch of our period. Goes from 2 pi to 6 pi. So we're going to see that in a couple of examples that we work through later on in this video. But here are the steps. If you end up having an equation that has a b in it, a multiplier in front of the x, these are the things you should do to graph your sine or cosine wave. The first thing is you should calculate your period by setting tau equal to 2 pi over b. Once you figure out your period, you lay off a distance of 2 pi over b on the x-axis starting at 0. And that's what we did when we were graphing the sine and cosine function where the period was 2 pi. We found 2 pi, and then we laid off the quartile and the half marks. We divide the interval into 4 equal parts, and these are our quartiles. We need to find the labels for each of those, and I'll show you how in our examples. Evaluate the function at each of these quartiles, plot the points and draw in the wave, and then draw additional periods as needed. So let's take a look at our very first example. We are going to be graphing y equals 2 times the sine of 3x over just 1 period. All right, so we have a couple of things in our equation that we need to take a look at. We have an amplitude change, so we should up here denote that we have an amplitude change. Our amplitude is going to be the absolute value of 2, which is 2. And then we have a period change. We're no longer at 2 pi for our period, so we're going to calculate our new period. We're going to divide, or b in this case. This is a, this is b. Our b in this case is 3, so we're going to divide 2 pi by 3, and this is compressing our period. Our period went from a normal 2 pi down to 2 pi over 3. Then what we're going to do is we're going to lay off 4 chunks on our graph, starting at 0. So I'm going to label 0 right here, but I'm going to count 4 tick marks. 1, 2, 3, 4. And why do I do that? Because I have to divide my period into 4 equal parts, and these are each of the equal parts. So how do I find the labels for those? Well, the labels for those, this point right here is just the midpoint between 0 and 2 pi. So how do you calculate midpoint? Midpoint is going to be 2 pi over 3 plus 0 divided by 2. It's just the average of two numbers. So if we divide 2 pi in half, we get pi over 3. So our label right here is going to be pi over 3. How do we find our first quartile label? Well, we do the same thing. We find the average between 0 and pi over 3, and that gives us pi over 6. So this is going to be pi over 6. And then for our third quartile mark, we're going to add 2 pi over 3, and we're going to add pi over 3 because they're the endpoints, the two numbers we want the average for, and we're going to divide it by 2. So I notice that in my numerator I get pi, and my denominator I get 2, so this is pi over 2. So the next thing they say is that we should evaluate this function. Well, first off, I'm going to find that 2, and I'm going to say my graph is going to go all the way up to 2 and down to -2, because we know the amplitude is half the distance between the max and the min of our graph. So now it says to evaluate our graph at each of these quartile marks. Well, I know if I plug in 0 into x, I get 2 sine of, what's 3 times 0? It's 0. I know the sine of 0 is 0. If I plug in pi over 6, I get 2 times the sine of, let's see, 3 times pi over 6 is pi over 2. So when I plug that in, the sine of pi over 2 is 1, and when I multiply that by 2, I get 2. When I plug in pi over 3, I get 2 times the sine of 3 times pi over 3 is pi, and the sine of pi is 0. 2 times 0 is 0. When I plug in pi over 2, I get 2 times the sine of 3 pi over 2. And 3 pi over 2 is -1, so 2 times -1 is down at -2. And then when I plug in 2 pi over 3, I get 2 times the sine of 2 pi. And I know the sine of 2 pi is 0, so 2 times 0 is 0. And the instructions here were just to graph it over one period, and that's what I'm going to do. All right, I want you to notice something before we move on to our next example. I want you to notice that when we plug in our quartile marks, our 5 quartile marks on our graph, we end up with the same initial values that we had. We were taking the sine of 0, the sine of pi over 2, the sine of pi, the sine of 3 pi over 2, and the sine of 2 pi that we initially had when we didn't have a period stretch. So we can just assume when we move forward, instead of doing all these individual calculations, that we can use these values for our quartile, half, beginning, and end points. Okay, so that's a big discovery because that'll make our graphing go a lot quicker. And that's really all we need to do. So when we're done, we definitely should box in our amplitude and our period, and we'll move on to our next example. So for all your homework problems, I do want you to find your amplitude and your period change. And let's see, let's move down to the next graph. So this graph, the amplitude, let's see what our amplitude is going to be. Our A value is in front of our trig function, so this is A, and our B value is the multiplier of x. So pi over 2 is B. So our A value is the absolute value of -3, which is going to be 3. So I know on my graph I'm going to count up 1, 2, 3 and down -3 because my graph is going to go up to 3 at some point and down to -3 at some point. Okay, so let's see. My period is going to be 2 pi divided by pi over 2, which equals 2 pi times 2 over pi, which equals just 4. The pi's cancel out, my period's 4. So again, I'm going to count off 4 tick marks. 1, 2, 3, 4, and I'm going to label this 4. And because this is just a basic number, this should be fairly easy. The midpoint between 0 and 4 is 2. The midpoint between 0 and 2 is 1. And the midpoint between 2 and 4 is 3. And it does say we need to do it over 2 periods, so I'm going to count backwards the same amount. And you see that I have a distance of 4 in this direction and a distance of 4 in this direction. 2 periods worth of data. All right, so let's go ahead and do our calculations. And I want you to notice again, when we plug in 1, 2, 3, and 4, we will probably get, or 0, 1, 2, 3, 4, we will get 0 pi over 2 pi, 3 pi over 2, and 2 pi. That'll help us. So let's go ahead and plug in 0. We get -3 cosine. What's 0 times pi over 2? It's just 0. I know the cosine of 0 is 1. 1 times -3 is -3. When I plug in pi over 2, I get -3 cosine of what is pi over, oh, I'm sorry, I'm supposed to plug in 2. I'm looking in the wrong place. I'm supposed to plug in 1. Sorry, I'm not following my own instructions. Plug in 1. We want to plug in these numbers on our x-axis. I'm sorry, when I plug in 1, 1 times pi over 2 is pi over 2. I know the cosine of pi over 2 is 0. So -3 times 0 is 0. When I plug in 2, I get -3 times the cosine of, when I multiply pi over 2 by 2, I get pi. So the cosine of pi is -1 times -3 is 3. When I plug in a 3, I get -3 times the cosine of 3 pi over 2. And I know the cosine of 3 pi over 2 is 0. And then when I plug in a 4, I get -3 cosine of, let's see, 2 pi. And I know the cosine of 2 pi is 1. 1 times -3 is -3. So when I go ahead and I draw this curve in, I get a curve that looks like this. But I do have to draw it over 2 periods because they did ask me for 2 periods. So now when I go backwards, 4 is the beginning of my period. So I'm going to match it to my 0 point. 3 is the first quartile mark. So I'm going to match this to my first quartile mark. I'm sorry, those are negative numbers. -2 matches to my halfway mark, which is up here at 3. And then my -1 matches to my 3. So I'm at 0, and I already have a mark at 0. So when I go ahead and draw this curve in, it should look exactly like the very first curve. And again, one last thing to point out are these values are my initial values.